Mass transfer. What is that? Well, it is the net movement of mass from one location, usually meaning stream, phase, fraction or component to another, where it can occur in many processes, such as absorption, evaporation, drying, precipitation, membrane filtration, and distillation. So, moving on, there are many techniques of separations, but don't fret. Today, we're going to learn only two of them, which are absorption column and distilled column. Let's begin with the distillation column. The first subtopic we are going to review today is the fundamental of distillation column. What is distillation? Distillation is the process where the liquid and vapor mixture is separated into its component of desired purity by the application and removal of heat. To separate mixture is based on volatility, where O less volatile mixture is heavy and has high boiling point, where O high volatile mixture is light and has low boiling point. A distillation column may use either trays or a packed bed to bring the gas and liquid into contact. It is used for many commercial processes, such as production of gasoline, distilled water, alcohol, and many other liquids. Way to calculate stages of distillation column.
Hello, my name is Nur Shahira, and I will explain step 2 calculating the stages using Merkabel-Tile method. The first stage is we need to plot equilibrium curve from the VLE data. Our second step is to plot 45-degree line where at this point y equal to x. The third step will be plot given composition where are the mole composition of bottom, feed, and distillate. Step 4, we need to draw Q line from XF and YF value. If the feed is a partial vapor or saturated liquid vapor mixture, the Q line will be not less than 0 and not more than 1. If the feed is at the saturated liquid, Q will be equal to 1. Then, if feed at the saturated vapor, Q will be equal to 0. Step 5, we need to draw operating line for rectifying section. This line is also known as ROL, the point of XD on the 45-degree line connected to this point where the intersection of Q line on the equilibrium curve.
I'm going to continue the part of calculating the stages of distillation column using the Merkabel concept. Found the XB, XF, and XD already plotted. For example, the Q is under a bubble point condition, which is Q equals to 1. So Q is to 1, the direction of the line will be a straight line. So it'll be gonna be here. Well, I think it's already straight enough. The next is we have to find the ROL, the rectifying operating line. To find ROL, we have a special equation, which is y equals to yn plus 1 equals to r plus 1 xf plus 1 r plus 1 xd. So this equation represents y equals to m, and this is going to be x plus c. So technically this whole part is c, which is the intersection of y. Okay, let's plot them. So this is here to here is your ROL. Ta-da! You already found your ROL line. Now we have to find SOL. SOL is stand for stripping operating line. So stripping is you just have to connect this point to XB point, and you get SOL line over here. So as you can see, this, you get a triangle. This is called the perfect triangle. We are going to calculate the stages, okay? To calculate the stages, you have to start from XD and straight to equilibrium. Noted, this is not very accurate. Next, you have to go to the point that reach the line of ROL, which is the blue line over here. So fall down the line over here, and the next stage is gonna be over here, the tiny one. It's already fall down to the SOL, so reach to SOL. Continuing the stairs kind of look of stages until you find until it ends to the XB point. So in total that we have over here is 1, 1, 2, 3, the tiny one is also counted, 4 and 5. As you can see, 1, 2, 3, 4, 5. So you have 5 stages. To calculate number of strays, you take the 5 stages and minus by 1. You minus by 1 because the 1 represents the reboiler. So you got 4, the total number of strays in this distillation column.
Hello, hello, do you need me before I fade away? Is this a place that I call home?
Ta-da! This is our pack column distillation prototype. Let's have a tour on our prototype. This is the feed that we're talking about, that 2 or more components are going to feed into the stream: rectifying section and stripping section. The substances is going to be high boiling point substances and low boiling point substances. Low boiling point substances will go up, rises up, and it will evaporate it. We'll go to the condenser. What happened in the condenser is that the condenser will condense the vapor that left from the top column, and we'll go to the reflux drum, which is way down over here. I'll go back to the rectifying to this distillation column. I want to talk about what are we doing with the straws over here. So the straws will represent the packings. Functions of the packings are to emphasize on the component separations. The more packing, the more pack will be, the more surface area the mixture will touch, will have contact with. So it will enhance the performance of the separation process. So back to our reflux drum is to hold the condensed vapor, so the liquid from the reflux can be recycled back to the column. So it means that the reflux drum holds the liquid from this reflux will be the recycle of it. That's the function of the reflux over here. It will recycle back to the feed, to the column, where it will be doing the same thing again and sending back to the condenser and to the reflux, and some part of it will be, this is the distillate. So distillate will have a product that we'll call distillant. Okay, that's enough about distillate. What reboiler does is very important because it will provide the necessary evaporation for the distillation process. The vapor from the reboiler will re-enter the tower again, and the vapor will then rise up into the tower. So technically same thing again, repeat. But what is very important is that the reboiler must have, reboiler works the heat based on pressure. So the pressure in the reboiler has to be higher than the pressure in the column. So for the volatile components to be functioning well.
To find what I've become, walk along the path unknown. We live, we love, we lie. Deep in the dark, I don't need the light. There's a ghost inside me. It all belongs to the other side. We live, we love, we lie.
important.